Hello everybody. Today we're going to learn how to find area and perimeter of rectangles and triangles in the coordinate plane. So first we need to do just a quick review. Remember that perimeter is when you add up all the sides. It's the distance around the figure. So if you'll look at this first box, the perimeter of a polygon is the sum of the lengths of the sides. And then over here on the right we have circumference of a circle. So circumference of a circle, that's the distance around a circle. And you can think of that kind of like the perimeter. Remember, a circle isn't a polygon. A polygon has straight sides, no curves involved. But circumference is the distance around a circle. Remember, you can find circumference by doing pi times diameter, or 2 times pi times radius. And then underneath here we have some different formulas for area. Area of a rectangle, they've got listed as base times height. BH, that's the same as doing length times width. A parallelogram is the base times the height. Remember, the base and the height of a parallelogram make right angles, right? So the height is going to be perpendicular to the base, not necessarily one of the sides. For triangles, whether it's a right triangle or any other type, you do 1/2 times base times height. But in a right triangle, the base and the height are the legs of the triangle. Area of a circle is pi r squared. And then they give you a formula for area of a trapezoid. Okay, so you do need to have those formulas memorized. This part right here that says the formulas will be given to you, they won't, so you can work all that out. Those formulas are not given to you on your end of grade test. You do need to know those. All right, so if a figure is drawn in the coordinate plane, however, it says to calculate the perimeters and areas on the coordinate plane, you have to find the side lengths of the figures. Those side lengths aren't going to automatically be given to you. If the side lengths are horizontal lines or vertical lines, then to find those side lengths, we can just count the boxes. This is what I'm going to write. Count the boxes. But if those side lengths are not horizontal or vertical, in other words, if they're diagonal, then we're going to have to use our distance formula. Remember the distance formula you learned back in a previous lesson. So I'm going to write use the distance formula. And then we'll write that formula down. Okay, so remember that the distance formula, D equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. All right, so make sure that you've written that distance formula down, okay? You will be using that sum. All right, so let's go to the next page. All right, it says to graph the given points on a coordinate plane and then use the distance formula to find the perimeter and area. So we're using the distance formula if it's a diagonal length, right? And we only have to do that, or the reason we're doing that is because that distance formula, it does tell you the distance between 2 points, and it also would be giving you the side length, the length of the side, right? All right, so first it says given triangle ABC with coordinates A at 2, -1, B at 5, -1, and C at 5, -5. So first I'm going to plot points A, B, and C. So if A is at 2, -1, would be here. And don't just put the point. Put the point and you need to label it with an A. Okay, B is at 5, -1. And I'm going to go ahead and I'm going to put my A on the other side of the point. And then C is at 5, -5. 1, 2, 3, 4, 5. Okay, and so it's a triangle, right? I'm going to go ahead and draw the lines. Okay, and then we're finding the area and the perimeter. So first I need to find the perimeter, right? We need to know all the side lengths. Well, side AB is a horizontal line. That's 1, 2, 3 units. Side BC is a vertical line, so we can count that one. 1, 2, 3, 4 units. Now I need to find the length of side AC. Now, I'm going to use my distance formula for this, although we could just use our Pythagorean theorem here because it's clearly a right triangle, but we'll do the distance formula. So, just to practice using that, so side AC, remember that A, I'm going to rewrite the points for A and for C. And let's see, that's x sub 1 and y sub 1, that's x sub 2, and that's y sub 2. So my distance formula says, take the difference in the x coordinates, so that'd be 5 minus 2 quantity squared, plus the difference in the y coordinates, which would be negative 5 minus negative 1 quantity squared. 5 minus 2 is 3, so that's 3 squared. Keep your radical symbol. Negative 5 minus negative 1 is negative 4. That negative 4 needs to be in parentheses. And then the squared, the exponent of 2 outside of the parentheses. Okay, 3 squared means 3 times 3, right? So that's 9. Keep your radical. Negative 4 quantity squared means, in parentheses, it means negative 4 times negative 4. If you wrote that, then you are saying negative 1 times 4 times 4, which would give you negative 16. That's wrong. Do not do that, okay? Negative 4 in parentheses squared, which is what you should have written, means negative 4 times negative 4, which is positive 16. Okay. All right, then 9 plus 16 is 25. And then we're doing the distance between 2 points. Remember, distance is never negative. The square root of 25 is 5, right? So this is 5. Oops, that's 5 units long. Okay. Now I'm ready to find the area and the perimeter. So to find the perimeter, remember we're going to add up all sides. So 3 plus 4 plus 5. So that's what? 7 plus 5 is 12. So just write 12 units. And then area is equal to 1/2 base times height, right? Area of a triangle, I should say. And then so the base and the height are going to make a right angle, which in this case are going to be the legs of that triangle, 3 and 4. So 1/2 times 3 times 4. So 3 times 4, I'm going to do 3 times 4 first, which is 12. Half of 12 is 6. So the area is 6 square units. Oops, there we go. So you want to have that units with the power to the power of 2. 6 square units. Okay. Let's try example 2. It says given square ABCD with coordinates A, -2, 2, B, 1, 4, C, 3, 1, and D, 0, -1. So we're finding that perimeter and area. So let's plot those points first. So A is at -2, 2. Let's see, B is at 1, 4. Let's see, C is at 3, 1, 1, 2, 3. And D is at 0, -1. Okay, let's go ahead and connect them. All right, now, if I want to find the area and the perimeter here, well, I have to know the lengths of all the sides, but you don't have any horizontal sides or vertical sides. So you're going to have to use the distance formula for each side. So let's be organized. Let's start with side AB. So, and I'm going to label it that I'm doing AB. All right, since I'm going to use my distance formula to make my life easier, I'm going to write, let's do that. Yeah, I'm going to write the points for A. and the coordinates for B. Now I'll use my distance formula here. So that's going to be 1 minus negative 2 squared plus 4 minus 2 squared. So that would be what? 3 squared plus 2 squared. So that's 9 plus 4. So I'm going to do the square root of 13. All right, we already know that 13 is not a perfect square. So I'm going to just leave this in that radical form for right now. So side AB is going to be the square root of 13. Now, I want y'all to see right here, it says this is the square, right? So then all the sides should be the same length. So all of my sides should be equivalent to the square root of 13. I know for sure that DC or CD because are going to have to be the same, right? Let's just double check. Let's try side BC and C if that also has the same length. So point B is at 1, 4, C is at 3, 1. Okay, so let's do our distance formula. So that'd be 3 minus 1 in parentheses squared plus 1 minus 4 in parentheses squared. So that's 2 squared plus negative 3 in parentheses squared, square root of the whole thing. 4 plus 9. Yes, it is. So that's the square root of 13 also. And then this side is also going to be the square root of 13. So actually, we didn't have as much work to do, did we? So when we find the perimeter, right, it's going to be, let me come over here, the square root of 13 plus the square root of 13 plus the square root of 13 plus the square root of 13, or 4 times the square root of 13. So we could leave our perimeter in radical form. Okay, we can also round to the nearest tenth. So I'm going to pull up Desmos. You guys can't see it right now, but I'm typing 4 times the square root of 13, and then I'm rounding to the nearest tenth. So that's 14.4 units. All right, now when we do the area here, so area of a rectangle is length times width, right? So, or area of a square is side squared. So let's do that. I'll just write length times width though. So that's the square root of 13 times the square root of 13. In other words, the square root of 13 quantity squared. Well, taking the square root of something and squaring something, remember that they're opposites. So really that's going to be 13. So the area is 13 units, square units, that is. All right, so 2 different answers for the perimeter depending on, because sometimes you'll see the answer choices listed in radical form, right? So those are your 2 possibilities. All right, so now I'm going to have you do some practice on your own. So go ahead and do problem 1, 2, 3, and 4. Yep, let's just do one, pause the video, and do problems 1, 2, 3, and 4. Okay guys, welcome back. So now that you've had an opportunity to try some on your own, you want to check over the work. So here's problem 1. And there's number 2. Let me move that down for you. You should probably pause the video on this one to check over. For number 3, you can, hopefully you didn't do too much on that. You can skip it. When I graphed points A, B, and C, we can see that they're all making a straight line. So I'm not really sure how that would be a triangle. Clearly the coordinates, one of them needs to be adjusted. But you can just skip number 3. All right, and then here's number 4. Okay, and then we're going to go ahead and flip the page. And we're going to go to number 5. And we're going to do this one together. So for this one, it's not on the coordinate plane. It says, how many feet of fencing will you need to fence in a rectangular yard 20 feet by 30 feet, assuming that you use the wall of a 30-foot long building for one side? Okay, so what we're going to do is we're going to make a picture to help us with this. So I'm going to make a rectangle. And you're supposed to be putting fencing along it, but it says you're going to use the wall of a 30-foot long building for one side. So meaning you don't need fencing around all of it. You only need fencing around 3 of the sides. So it was 30 feet by, it said 20 feet. And so again, we don't need to put fencing around this side right here. So when I'm doing perimeter, but I'm not going to add in that 30-foot side that's right there. So I'm only going to add the 20, the 2 20s, and the 30. So I'm going to do 20 plus 20 plus 30. So I get 40 plus 30. Oh, which is right here. So that's going to be 70 feet of fencing. So be careful, this wasn't a true perimeter problem. All right, we're going to skip over problem 6, and we're also going to skip problem 8. So please write the word skip across those, and we're going to do number 7. For number 7, you're asked to find the perimeter of the triangle, and notice that this is multiple choice. Also notice that all of the choices they have radicals in them. So we don't need to find the exact value for each of the distances. All right, so perimeter is the distance around a figure. So the sides of this triangle, none of those are vertical and none of those are horizontal. So we'll have to use the distance formula to find the length of each side, which means we're going to have to do the distance formula 3 times. Okay, so we're going to organize our work. So let's start off with side BD, and I'm going to come over here and label it BD. And it's a line segment. Remember that line segments have that little bar on top. I'm going to write down the coordinates of point B and point D here. So B is at -2, 3, and D is at 2, 6. Okay, so when we use our distance formula, remember we're going to take the square root and we're going to subtract the x coordinates first. So I'm going to do 2 minus -2 in parentheses squared plus 6 minus 3 in parentheses squared. 2 minus -2 is 4, so that's 4 squared. 6 minus 3 is 3, that's 3 squared, and we're going to bring down the radical. So that would be 16 plus 9, square root of that, so the square root of 25. Remember that when you take the square root of a number, there are 2 square roots, the positive root and the negative. But since you're doing distance here, you only need the positive root. So the square root of 25, we're going to list as 5. I'm going to write that over here. So we found side BD. Let's do side DE next. So I'll come over here, side DE. And point D we said was at 2, 6. Point E is at 1, 2, 3, 2. I'm going to make a line there. All right, so now I'm going to use my distance formula again. So we're going to do what? 3 minus 2 in parentheses squared plus 2 minus 6 in parentheses squared. So 3 minus 2 is 1, so that's 1 squared. 2 minus 6 is -4. That -4 needs to stay in parentheses and then the squared outside. All right, 1 squared is 1. -4, that quantity squared means -4 times -4, which is 16. Now 1 plus 16 is 17. When I do the square root of 17, remember that will be an irrational number. So, and remember in our answer choices, we saw answers with radical signs. So let's just leave this as the square root of 17, and we'll write it on the side. Okay, now we need to find the length of side, or the distance between points BE, or the length of side BE, same thing. So I'm going to come over here and do that. So BE. So point B is at -2, 3, And E is at 1, 2, 3. We said 3, 2. Okay. So that distance is going to be 3 minus negative 2 in parentheses squared plus 2 minus 3 in parentheses squared. So 3 minus negative 2 is 5, so that would be 5 squared. 2 minus 3 is negative 1, so that's negative 1 in parentheses squared. Let's come over here. 5 squared is 25. Actually, let me write the d equals first. And I'll go ahead and do my radical. So 5 squared is 25. Negative 1 in parentheses squared is 1. So this would be the square root of 26. 26 is not a perfect square, right? So I'll just leave that for now as the square root of 26. All right, so now when I find the perimeter of this triangle, I'm going to do 5 plus the square root of 17 plus the square root of 26. And we can see that answer choice A has those same 3 quantities being added, although it is in a different order. So this is going to be choice A. Okay? And then again, I said that we can skip over number 8. All right, so that's it for this lesson on area and perimeter in the coordinate plane, which is really just you using the distance formula, right, when you have a diagonal segment. If you have questions about this video, this lesson at all, let me know so that I can assist you. Go ahead, turn this in. Please make sure you've shown your work. But go ahead and turn this in, and let's get started on your independent practice. Good luck.